Perfect. Okay, if you haven't seen the board, book check-ins for us is on Friday this week. So I'll be taking your book. If you have multiple books at home, I want them, okay? I'll be taking them in class. You can take off the book covers when you turn them in that day. Don't take them off beforehand. All late work for me. So if you check the grade book, you can see there's any LIs or missing scores or zeros. You need to get all late work in by Friday this week. Otherwise, I don't take it. Got it? It stays forever zeros. And I haven't even entered zeros yet. So like that, your grades could significantly drop by entering zeros for late work and whatnot. So keep that in mind. Semester test for you guys is a week from tomorrow. So a week from tomorrow. We'll start reviewing that on Wednesday this week. You'll get the practice guide tomorrow, but we'll start reviewing Wednesday, Thursday, Friday, Monday. And what I mean by review, we only take like the second half of the day to review. I think my semester test for you guys is like 15 or 16 problems, I think. So we do like the review, we do like 4 problems each day on the review, and then next Tuesday you can take it. Okay? Does that make sense? All right.
No, don't open part one.
Yeah, part one doesn't work so well. Okay, we ready to go?
Yes.
Perfect. Okay, let's take a few notes today. The outline is on the board of what we're going to be doing today. We're going to be talking about polygons today, which are shapes. This is what everyone thinks of geometry. We talk about angles, we talk about planes, all that good stuff. So we're talking about the shapes of geometry. So we're talking about polygons. So section 7. I think it's 7.3, 7.4, but we'll call it 7.3. We're talking about polygons.
Last one, pretty much.
4.
But
Yeah.
do we have one more?
We have 2 more sections. We talk about measurements, how to measure objects. Okay, so the idea is that we're talking about polygons. We're gonna do this today and tomorrow. We'll do measurements Thursday, Friday, or I should say Wednesday, Thursday, Friday. We'll do measurements. So this week you will have a couple of assignments this week. We'll have an assignment probably tomorrow. We'll have probably an assignment Thursday. Everything's due Friday. Okay. So pretty straightforward, pretty easy. So, but again, what we're going to be talking about today, we need to talk about the definition of what a polygon is. Most people don't know the shapes, but they don't even know like what a polygon means. Like what are the different names. So we're going to talk about that. Then we're going to go immediately into the classifications. Like what are all the different names?
Shapes.
Yep, the names of the unique shapes. Yep, they're called polygons. If we go to 3-dimensional, then they're polyhedra. When we go to 3-dimensional.
Polygon. So that's a Pokemon.
It probably is. All right, but we're gonna do classifications. That's kind of our goal. We have a lot of different names. This is gonna get a little confusing. I'll try to do my best to try to simplify it for you guys. So I think you guys are kind of like, we'll do some drawing today and stuff, and see if you guys are pretty good at it. But you do need notes, so take your notes out here. You should not need a calculator today. A lot of just words and stuff.
Are we using our computers for notes?
Nope, you won't need your computer. So you just need a piece of paper and pencil today. So paper's in the back. We don't have any.
Are we gonna use our computers again?
Let's see, we might use them maybe Wednesday, Thursday this week. Maybe?
Thursday won't be normal, because we have to send out for track.
Yeah, but we'll have we have most of our class anyway. Okay, so let's jump right in. Let's talk about the classifications. Goal today is to get all the names and all that good stuff. And so we have a lot of different vocab words. Hopefully that I can keep these straight for you. Okay, let's talk about the word polygon to begin with. The word polygon, right? The generic shape. Polygon is this is what the book says is definition. It's composed of many angles. That is the dumbest definition I've ever heard. Super dumb. Like it doesn't explain.
At least it's super short.
Yeah, it doesn't explain anything. It just says this shape has many angles. It doesn't explain how to draw the shape. It doesn't explain what it should look like and the rules for it. It just says it has angles in it. Fine, you guys know what angles are, right? We've been measuring them for the last couple days. The problem is like there's a lot of rules to when you draw a polygon. Number 1, they have to be made of segments. We talked about that in class. Coplanar segments, that's a new word. They have to be on the same plane. These have to be on the same plane, which is a flat surface, right? Planes for us are like the marker board's a plane. And they have to be segments, straight lines like this, connected together. Now, there's rules for connecting all these segments, right? Here's the rules. Number 1 rule, when you draw these segments, they have to be connected to 2 or more others. So this stick that I have drawn on the board here, let me move it over here. This stick has to be connected to 2 or more other ones. So if this has to be connected to 2 or more, this is the bare minimum number I could have. What is that shape?
Triangle.
It's triangle. That's the first type of polygon we have. That's the first name. We'll get to the names here in a little while. But each stick has to be connected to a minimum of 2 or more. So that would be the first shape, because each stick is only connected to 2 others. Okay. Now, there's segments, right? They have to be straight edges. The segments themselves have to connect at endpoints. They can't cross over each other like a bow tie. You can't have a picture that looks like this. This is not allowed. That doesn't work, because they're crossing over each other. You can't have that. They have to hit on only the endpoints, the end caps. Yeah, you can't have that. This, don't draw that picture. You cannot draw that picture. That's not allowed. Okay? They have to be connected at the outsides. Okay? They can't cross over in the middle. The other thing is, they can't be in straight lines with each other. And I even say this, they cannot be collinear or in a straight line.
How about a circle?
Nope, because a circle doesn't count. Because is a circle contain a segment? Straight lines. No, circles are curves. Circles are called conics. Conics is circle. Conics. We're not dealing with conics. That's circles and cones and whatnot. Cylinders. So these are the things that we will eventually look at later. Those will be later sections, if we can get to them. But we're talking about straight lines that connect. So why am I doing straight lines? We can measure them. We can use rulers and all that stuff, which I said we're going to do at the end of the week. All right, we're going to be measuring things with straight edges. You guys are pretty good at that. We've done that a long, long time ago when we did the math stuff. So you guys are pretty good at measuring objects. But it's nice to get some more practice to see why we do it. Okay, questions so far? Okay, those are the 3 basic rules. Now, I've used, if you notice, some of these words have been in air quotes, like the words endpoints. Well, endpoint has a different definition. If you want to call them endpoints on the corners, like where these dots are, they're also called a vertex. That's where the dots are. They're called a vertex or vertices, if you want to go plural. They're the points of intersection where things cross. So this is called a vertex. If you want to go plural, vertices. Okay, now the walls of this object, they're called edges. The sides are called edges of the polygon, or segments. This is an edge. One of the sharp facing sides. Okay, are we good with that? Okay, is everyone comfortable with vocab words? Vertex are the corners, sides are the edges, segments have to be the actual edges and the sides that are connected. Perfect. All right, now, most people can get a sense for, okay, we got to draw with straight lines, no curves, nothing like that. But there's certain stipulations when you draw. Here's my stipulations when you draw a polygon. There's 2 words here. And these are the definitions your books actually say, which I hate these definitions. There's 2 words. There's convex and concave pictures. I'm going to draw a picture of each. Ignore these definitions. These are just meant to confuse people, I think. Okay, so here's the definition. All right, so the first one, convex. This is a convex picture. It's a 4-sided figure. Kind of looks like a rectangle box, kind of a thing, like a square. It's not meant to be. It's just random, right? So
Half
convex
rectangle,
picture.
half square.
Yeah. So, right? Convex, very easy. I think it looks like a big fluffy pillow. Fine. Concave, same 4-sided figure. Has 4 walls, right? 4-sided figure, but now it's concave. That's 4-sided, and it's concave. What's the difference between the 2 pictures?
One's a square and the other's a triangle. It looks like Star Trek.
It is. It looks like the Star Trek symbol. Very good.
The arrow.
Kind of looks like an arrow. Here's the difference. This one has a cavity. Has a cavity.
If you take these 2 on a computer, all they really did was click the middle thing and drag it up.
Yeah, basically, yeah. It has a cavity, or it has a mouth, like Pac-Man. If there's a dent on your picture, a cavity, that's concave. It's got a cave to it. It's It's got a cavity, right? If it doesn't, it's convex. Now, what this is trying to explain, this is the goofy part. A lot of people look and go, okay, what are those words even saying? What it's saying, that when you're to connect any two interior points, pick any two dots you want, and draw a line that connects them, a straight line. Did that line cross the outside of my picture?
No.
No, so that's why it's convex. If you pick any two dots down here, and I always try to put them in such a way, I pick two dots. See my two dots I picked? Draw a line that connects them. Did that line cross the outside?
Yeah.
Yeah. That is concave. That's what those words are trying to explain to you. That's difficult, I understand. But again, my trick is you draw the lines connecting. Okay. Questions, comments about all this geometry stuff?
Nope.
Okay, let's get to the names. These are the parts that most people like. They like to get to the names of these polygons. The first one, same you said earlier, what is the first type of polygon we have? You said it earlier.
What is a triangle?
Triangle. Triangle's the first one. Here's the picture of it. That is a triangle. It's got 3 walls to it. That's the bare minimum side. Each side, each wall, each edge has to be connected to 2 or more other ones. That's the bare minimum. There's a lot of different types of triangles. In fact, that's what we're going to look at today and tomorrow. There's actually 6 different types of triangles. It's actually 7 technically.
I was going to say
There's 7 technically, but we'll get to it. Okay, so triangle. Second one. Most people think a 4-sided figure. Right?
Square.
Say it.
Square.
Most people think square. It's not.
Also known as a diamond too.
Also known as a diamond.
Fields
Which,
of-
that's not the words I'm looking for yet.
Venom?
You, sir.
What? No. Here it is. Four-sided object. It's called a quad. Quadrilateral. Quad means 4. It's like a quad ATV, right? It's got 4 wheels. Quad is a box-looking shape that has 4 walls. It does not have to represent a square or a diamond. That's a random picture. In fact, each of the walls in this picture I picked, they're all different sizes. Kind of looks like a triangle, but it's not. So there's a lot of different types of quads, and we're going to look at those tomorrow as well. Okay, maybe even today. Well, I might start triangles today. We'll see. Okay, we're good with those so far?
Oh, yeah. Keep
Okay, next one. Pentagon. 5-sided. Here's the Pentagon Building in Virginia.
going. Yeah.
Can I go use the bathroom?
Yes.
Yeah, that's in
So-
Virginia.
That's in
Yeah.
Virginia. Okay, the Pentagon Building is unique. What's unique about that building is that it's got 5 walls, also known as a pentagon. That's why they call it the Pentagon Building. But what's special about that building is that every wall of that building are all the exact same size. They made it perfect. In fact, every angle in the corner of this building is exactly the same.
You can make a star inside of it too.
Yeah, and they actually have another pentagon in the inside, and then they have a garden on the inside.
I
of
just
that.
want to figure that out.
Yeah, it's a very, very weird building. Like, they designed it very peculiar. Why they picked it?
That's inside the
So-
Pentagon, like that one.
Yeah, and one of the reasons why they do that, it sees every angle, and there's no corners that are blind to you. You can see every side of that building without being blind, because the corners can hide stuff.
Isn't that where? I forget what you do in that building.
FBI is usually based in there.
Yeah.
Any central intelligence agency is in there. CIA, FBI, all of them. Okay. NRA, all those acronyms you can come up with. Okay. All right.
They should make a limit of how many abbreviations they can put for police force names and stuff like that.
POI.
All right. Let's move on. None of you can tell the joke I just made.
FBI.
So, all right. Hexagon. Hex means 6. I remember hexagon. It literally has an X like the number 6.
Stop sign.
So not a stop sign.
Still is the same shape.
No, it's not.
Actually, no.
No, it's not. It's missing a couple walls. 8-sided to be a stop sign. If you look out there, you can see it. Okay, 8-sided is a
Touche.
So a little bit different. Now, where you see a hexagon, this is honeycomb.
Oh.
Honeycomb or a bee's nest would actually be based in a hexagon shape. The actual protein crystals and bacteria grow in hexagon shape, so it does happen in nature quite a bit. Kind of a cool shape, but again, hexagon or 6. 7-sided is called a heptagon or septagon. There's 2 different names depending on Latin versus Roman. Heptagon is usually the one I use. Heptagon.
Something God.
For 7-sided, I don't have a picture of it, but it's 7-sided. So, moving on. 8 is an octagon. An octopus has 8 legs. octagon has 8. That is your stop sign.
Mm.
The stop sign has 8. You can see them there. There's 8 walls to that. 1, 2, 3, 4, 5, 6, 7, 8. 8 total walls. Okay. Next, 9. They call it a 9 gun. They didn't get real creative with that. Or it's called
Nine-a-gon.
or it's called a nonagon. Yep. 9-sided polygon. It's called a nonagon. Okay. So these are the basic names that I use. I use nonagon a lot. I like that word. Decagon is 10. Deca is the Latin word for 10. We use that in the metric system.
Yeah, it was like.
Decameter, decaliter, decagram means 10, multiples of 10.
You can go up if you want.
11gon or hendecagon. Hendecagon, hen means 1 more than a decagon. Decagon is 10, so 1 more than 10 is 11. And then dodecagon is 12. That means 2 more than 10. So, do is the Latin word for 2. Okay, questions at all about those others? Now, I didn't have pictures of all of them, I only had pictures of the main ones. I might, maybe as a kind of a mock tomorrow, I might try to see whether you know your names, how many walls there are. Depends on what type of name it is. I would like you to write these names down today, if you can. So, I'm gonna leave that slide up there for a little bit, and then we're gonna move on to the triangles. So I'd like you to write down all those different names. Don't know the pictures, because we don't have it. But it starts with a triangle, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Those are your walls. Write down those names, please. So, again, write down all those names. I'd like you to write those down, please. So again, I said you have to be in kind of the front 2 rows. It's kind of hard to see those, they're kind of small.
I am in the front too.
And then tomorrow I'm going to see whether you can remember some of them. So,
Oh,
that might be
you
one
don't
of
have to
those.
go over. You don't have to go over it once with me.
I'll probably either get to 4 or that, or if not, then I'll be able to go to 6 at least.
So just remember, know the word, but also know how many walls that is. It starts with triangle means 3, and then quad is 4, pentagon is 5, and 6, 7, 8.
I'm just
9.
abbreviating all these.
So.
Look up, I'm just saying them. Look up BCC trolling.
Alright,
He's hilarious.
so let's you copy these down. Then we're going to get to the specific types of triangles today. And that's probably where we'll end. We'll end with triangles today. We'll just focus on that. Tomorrow we'll focus on quads. And then I'll test whether you can remember some of these names.
Here.
We'll do a little activity probably near the end today.
No, it kind of sucks that you have to buy PlayStation Plus now just to play online.
Okay, gets it. I have the new God of War game.
The reason why I'm not happy with Sony and Trump. Trump took away the law that said the internet's free.
Okay, you ready to go?
I'll get it soon.
No. Hexagon? Is that even a thing?
Hexagon, 7 gun, yeah.
Two fighters are getting into the octagon.
Get started. That's your stop sign. Octagon shape.
Excellent. Pentagon.
Nonagon, no, 9-gon, they get real creative with that.
John John.
God.
9?
Yep. Nonagon. so let's go on and let's talk about triangles only. Triangles only, okay? A triangle is classified by number of sides. So tri is the root word for three, right? Tricycle has 3 wheels. So tri means 3 sides and has 3 vertices, 3 actual corners. So there's 3 letters here, A, B, and C. There's 3 letters, that's the corners, okay? Now, the big thing, what most people don't know, is that there is 7 words for triangles. 7 words. Most people just don't remember them. They just don't remember like how they fit. There is 2 ways to name a triangle. Every triangle has 2 names. So I'm going to give you triangles here in a minute. Okay? You guys are going to get different style of triangles. Each one of these has 2 names. There's 2 names per triangle. And they can be different. Some of these triangles could have the same names. But every triangle has 2 names. One of the ways you name triangles are by its sides. So if you were to measure how long the walls are, like that's what we're going to be looking at later this week.
Equilateral or acute.
Those are angles, right? So we're going to be talking about those. So the idea is that we can measure by its side lengths. We'll get to the 3 words here in a minute. Then you can measure by its angles, and you said acute, like that's one of them. These are the things we use to measure. Now you guys should be good at angles. We've done that. So, but the new thing we're going to be going to later this week is measure its walls using a ruler. Okay? All right, so let's get to it first. So if we're going to measure a triangle by its sides, here's your names. Okay? So here's your names. It's 3 names you can call a triangle. It's called scalene, which looks like this. This is what a scalene triangle is. Scalene triangle usually has no marks. It's where all 3 sides are different. What I mean by different, all 3 sides are different lengths. All 3 sides have different lengths. So whatever the walls are, so you can call them, maybe you measure this. This is 4 inches. This one's 3. That one's 2. They're all different. Okay. Second word is called isosceles. That's where 2 of the walls match. This is the picture. You notice the little marker. Yep, isosceles. I spell it wrong all the time. Isosceles. It's where 2 of the walls match. So if you're to measure this, maybe this is 4 inches and 4 inches. The other wall can be any length you want. It can be more, it can be less. This could be 5 inches. This bottom one could be 3 inches for all I care. As long as it's different than the other 2. Does that make sense? Okay, the last one is called equilateral. Equilateral triangles where all 3 sides are the same. You can see the marker. So whatever you measured it out to be, maybe it was 4, 4, and 4 inches. Fine, they're all the same exact number. Okay? So here's my question. If you looked at this picture, which one of these 3, scalene probably, right? Because it looks like all 3 walls are different. This wall looks the biggest. This is the middle, this is the short one, right? So it is a picture of a scalene. What about?
Actually, that's not true. It is the bottom part and the top part are the same length.
They're not. I can show you here in a minute.
It looks
why
like a
they're
shark fin now.
not. This one. I'll show you why this is true. This one.
Isosceles.
Nope.
Equilateral.
Equilateral. All 3 sides are supposed to be the same. So I think I measured it out to be. It's supposed to be. Okay? Actually, no, no, that's still equilateral. Equilateral again.
Sicily.
Okay. This one.
Isosceles.
Nope.
Scalene.
Scalene. Isosceles doesn't happen very often. I don't have any pictures. Now, how do we know? Because I counter asked, like, how do you know it's not isosceles? Here's how I can tell. This is the easiest way that I can explain to you. When you look at a triangle and you hold it up like this, and you think, okay, that wall and this wall kind of look like the same size. Is this peak right above the middle?
Nope.
If it's not isosceles. That's how you can
or
tell.
that you can just tell one side's
So-
curved and one side's not.
So, these, yeah, they kind of look like they're on the top and the middle, but all the walls are supposed to be the same sizes.
Pyramids!
So, okay. So, they're kind of rare. Isosceles where 2 walls match, even more rare, 3 sides match. I was trying to just come up with random pictures of it. Okay, the last slide here today, last slide. How to measure a triangle by its angle measures. Angle measures, you're gonna have acute triangles. That's where all the angles are less than 90. All angles are less than 90. Less than 90 degrees. 90 degrees, if you didn't know, is that's the L shape. or less than 90. In fact, here's a good example. Every angle in this picture is less than 90. No matter how you hold it, all these angles are less than 90 degrees. There's no L shapes in the corners. Make sense? This one has an L shape, if you can see it. Has an L shape in the corner. That is called a right triangle. It has a right angle in it. So it has a right angle in the corner. They usually put a box there. I don't have a box in mine. But it has a right angle in it. Now, if one of the angles is too big, where it's bigger than 90, that's where it's called obtuse. Do you see that this angle is obviously more than 90 degrees?
Oh, yeah.
Okay? More than 90, it's obtuse. Okay, here's what I'd like you to do. I'm gonna give you one of these triangles, and I want you to come up with your two names for them. Let's see if you're memorizing them.
2 names.
Two names. Tell
Oh, yeah,
by sides.
they have 2 names.
Scalene, isosceles, equilateral, or one of these? Okay, boom, boom, boom.
Oh, wow.
Okay, take your triangle, go to one side, put your name on it. One side. So I'm gonna take mine, I'm gonna put my name on it. I'm gonna write Mr. Ward, right in the middle of it. Okay, now what you need to do, you need to pick one of these words on this side. Is your triangle acute, right, or obtuse? If it's acute, every angle in the corner is less than 90 degrees, it's less than an L shape.
I know
Acute.
mine.
Mine is acute.
Mine's right.
Okay, so, okay, yours has a right angle, like a perfect L, but right on this side. If one of the angles is more than 90, so it would be where you're past that L shape. So my good examples there is when you hold it, so it's flat against your desk, and it goes past the L shape, it goes that way. Now this is the L shape, the 90 degree, you went past it. The good way to do it is you put it in the corner of your desk, and you see if it hangs off the edge of your desk. That's the easiest way to do it. Hangs
yeah,
off
do we
the
also
edge of
call-
your desk,
do
it's
we also-
definitely,
Do we also put our
Now.
triangle names up?
yep, so now, flip it over. So yeah, so if you pick one of these words on the side with your name, now flip it over, you should be on the blank side now. Now you're gonna pick one of these 3 words. So now you gotta figure out, is it scalene? Are all 3 walls different? Is it isosceles? Are 2 walls the same? Is it equilateral, where all 3 are the same? Okay, you're just gonna eyeball it. To me, mine is actually isosceles, this one is. Here's how I can tell. This point right here is not above the middle. So it's definitely not equilateral, but this side is. That's above the middle. So mine is actually isosceles. 2 of the walls match in this picture.
Mine's completely different than yours.
So that's where 2 walls matched. In fact, these are the walls that matched. If all 3 walls match, put equilateral. But you have to hold it up and see if that actually works. Because how I can tell, if you hold it up and that one of the peaks is not above the middle, it's not going to be equilateral. It could be. Okay, once you have your 2 names, one should be on the side with your name, and one should be on the other side. I'm going to take them. Let's
Oh,
pick your name. Perfect. Okay, boom. Okay, all right, let's go through these. I'm not gonna say names or anything like that. Okay, first one. Okay, this one, we have equilateral. I probably agree, it looks like it's equilateral. All 3 walls look the same, and it's acute. All the angles are less than 90. It's
Just so you
good.
know, I wrote down the words for the other slide that you went from.
Okay,
I didn't
so,
actually put it in the triangle or anything like that.
all right, so this one's scalene. I agree, all 3 walls are different. It is a right triangle. That's good. There is a right angle in the corner. Has a perfect L shape. This triangle is scalene. All 3 walls are different. You can definitely see that all 3 are different. And it is a right triangle. It's perfect. So it looks like you guys got a pretty good handle. Remember, every triangle has 2 names. Got it?
Yep.
Done for the day. Very nice reads.
How much longer do we have left of the class?
8 minutes maybe.